In the night sky, it looks like a bright star. 370 years ago, Galileo looked at it for the first time through a telescope. He saw a disk with points of light like stars spread out on either side. Night by night, their position changed. They were not stars, but moons. The motions of Jupiter's moons confirmed the Copernican theory of the universe, and models were made to demonstrate that the planets all revolve about one central body, the sun. But for 370 years, unsolved mysteries accumulated around the giant planet. There is a huge red spot, 3 times larger than the Earth. And during the First World War, British soldiers heard interference on their radio sets. The source was the planet Jupiter. Now we have seen it close up. Jupiter is stranger than we ever imagined. Pasadena, California. Here, during the early 70s, a great scientific adventure was planned. The aim was no less than to explore the entire outer solar system in one go. That immense journey is now well underway. Mission control is here at NASA's Jet Propulsion Laboratory, JPL. For just 1 month every 175 years, the planets line up in such a way that spacecraft from Earth can visit each planet in the outer solar system in turn. NASA planned to launch 2 spacecraft in that month in the autumn of 1977 to Jupiter, Saturn, Uranus, and Neptune. The trip is called the Grand Tour. After Saturn, 1 spacecraft would visit Uranus and Neptune. The other would travel up and out of the disk in which all the planets revolve into outer space. Would they survive the hazards of such a journey? Hazards like asteroid storms and radiation belts. So first, ahead of time, in 1972 and 1973, NASA launched 2 relatively unsophisticated spacecraft to Jupiter as probes to see if the journey was possible. Pioneer 10 and Pioneer 11 survived the voyage. They proved it was possible. They also sent back pictures of Jupiter, pictures that showed the giant planet clearly for the first time ever. This is the red spot. The stage was set for the Grand Tour. That special month started in late August 1977. Miss it, and it is necessary to wait until the year 2152. Within 14 days, NASA launched Voyager 1 and Voyager 2. The spacecraft sat on the most powerful rockets ever assembled, more powerful even than the rockets that sent men to the moon. Boosters were to throw the spacecraft out past Mars to Jupiter, Saturn, Uranus, and Neptune, and on into outer space. The first leg to Jupiter, 500 million miles away, was to take nearly 2 years. The Voyager spacecraft were the very best that current technology could provide.
I'm standing beside perhaps the most sophisticated brain that's ever been put in space. This here is really 3 large computers that sense its orientation, remember commands that have been transmitted up as much as a year beforehand. The way that the spacecraft is powered, since it's moving out away from the sun, beyond Mars, through Jupiter's system, beyond that to Saturn, and beyond Saturn, is with nuclear batteries, not with solar cells. These nuclear batteries, which are on this large boom here, are powered by plutonium, which produces heat. The heat is then used to drive, in effect, large thermocouples, which produce the electrical power steadily that powers the spacecraft. The scientific data of Voyager are sensed by these sophisticated sensors, and especially this long focal length camera here, which is capable of seeing detail in almost as much clarity as a large telescope on the Earth, for example, looking at the moon. The large antenna here beams the radio signals to Earth, where one of 3 large antennas on the Earth receives the signals and transmits them back to JPL.
Goldstone, California. This antenna is in contact with the Voyager spacecraft. There are 2 more just the same in Spain and Australia, spaced across the globe so that there is always at least one antenna in communication with the spacecraft.
The antenna is tracking Voyager 2 spacecraft, which is about 500 million miles from Earth. The spacecraft is transmitting at about the power of a 20-watt light bulb, and we are receiving television pictures from the planet and the spacecraft at this time.
This computer animation shows a speeded-up view of Voyager 1's encounter with Jupiter. The entire event was to take 40 hours. First, Voyager 1 flies close by Jupiter itself. It benefits from the enormous gravity to be flung out on its path to Saturn, passing Jupiter's planet-sized moons on the way. The trajectory of the spacecraft had to be minutely planned so that each object of interest would pass beneath the cameras and other instruments on board. This perfectly timed gravitational dance took years of background work to coordinate. Back at JPL, a new breed of engineer was born, the astro-navigator. Monitoring the information coming back, they could check that the spacecraft were obeying the lengthy programs stored in the onboard computers. But at the actual moment of encounter, they would be helpless. If the spacecraft collided with a moon, the NASA engineers would only learn of the disaster 45 minutes later, for that is the time it takes signals traveling at the speed of light to pass from Jupiter to Earth. Each encounter was planned so that footprints of pictures would be taken to cover whole areas of surface with overlapping frames. Information comes back from the spacecraft in digital form as dots and dashes transmitted at high speed. Most of the information is in the form of black and white still pictures. The signals are interpreted by computer. Each picture is made up of 640,000 dots. Voyager can photograph the same scene through different colored filters. These 3 black and white pictures can then be filtered and assembled to make one color picture. The result is something rather more than a simple picture. It can be processed and enhanced to reveal all sorts of pictures within it. And sequences of pictures can be animated to make movies. Here, speeded up 500,000 times, is what the Voyager spacecraft actually saw as they approached Jupiter. Close in, the Voyager pictures show a lurid, twilit world. Out here, the sun is only a bright star. Strange, abstract shapes pattern the planet. The visible surface is all clouds. Occasionally, moons the size of small planets are seen orbiting the cloud tops. Jupiter is truly immense. In fact, you can fit no less than 11 Earths side by side across Jupiter's diameter, and more than 1,000 Earths into the entire volume of the planet. But it's not only size that makes Jupiter quite different from Earth. Both the Earth and our moon are made of rock. In that respect, they are both typical of the planets of the inner solar system. Mercury is much like our moon. Venus has an atmosphere. Like Earth, that atmosphere is thin, and there's a rocky planet underneath. The same goes for the remaining inner planet, Mars. But Jupiter is quite different. It is not solid at all. It is made of hydrogen and helium gas. Underneath a turbulent atmosphere is an immensely deep ocean of hydrogen. In the inner portion, it is so compressed it behaves like a liquid metal, and perhaps at the very center is a small rocky core, rather larger than the Earth. The interior is still hot from the planet's formation 4.5 billion years ago. Could any form of life exist here?
The possibility of life on Jupiter is, I think, rather remote, partly because it's quite cold. The clouds that we're looking at, for instance, are about minus 150 degrees centigrade. Now, it is indeed warmer deeper inside of Jupiter. In fact, if you go down to the center of Jupiter, it's 20,000 degrees. And so somewhere between 20,000 degrees and minus 150, there is a temperature near room temperature. But we also believe that because of the source of heat inside of Jupiter, which is causing the winds now on the surface of Jupiter, there's a great deal of up and downward convection. And so that any bit of material does not reside at a nice even temperature, but is brought up to where it's frozen, very, very cold, and then it's carried down to where it's heated until it's very hot. And that cycle would essentially destroy any very complex molecules in a reasonably short time.
Jupiter's surface is covered in red and white spots. The biggest, the Great Red Spot, is 3 times larger than the Earth. It is seen in this picture with the color enhanced. It looks like an enormous rotating hole reaching down to a deeper level of clouds underneath. Here, speeded up 500,000 times, is a movie taken in ultraviolet light of the red spot. Before Voyager, it was thought to be a vast rotating storm, like this hurricane on Earth. This is a working laboratory model of a hurricane. It has quite a distinctive structure. The inward flow is all at the bottom. The clouds on top just swirl around in circles. The red spot doesn't behave like this at all. So the one thing it isn't is a hurricane.
A group of us have been working on the idea that the red spot is a solitary wave now. A solitary wave is a wave in which the tendency of the wave to flatten out, because it's higher than its surroundings, is exactly balanced by its tendency to break, rather like the waves on a beach break. Since we can't do exact experiments on the red spot in the laboratory, we are now looking at an analog flow. And I'll show you this analog experiment. What we have are 2 layers of fluid. One is a heavy layer of salt water, and above it is a light layer of fresh water. And I'm going to mix up this fluid in this section right here. And when I mix up the fluid in the tank and pull out the barrier, you'll see this solitary wave develop in the flow, and this is our analog, if you wish, of the red spot.
This solitary wave certainly looks like the red spot. But is it? As yet, there is no real agreement among the Voyager scientists about the true nature of the real red spot.
Well, studying Jupiter, in fact, for the first time, particularly if you have no knowledge of meteorology, you would imagine that it's very different from the Earth. But one of the most exciting things that have come out of the Voyager mission is that the Earth and Jupiter are very similar in terms of their weather systems. In the case of the Earth, we have the situation that our weather is driven by the sun's heating, which has this difference in temperature between the equator and the pole. Now, on Jupiter, this is different. The sun is very much weaker, and the temperature at the equator and the pole are roughly the same. And of course, there is a further additional source of energy, namely internal heating. So that gives you initially a difference. But where the similarity comes in are these belts and zones, which we believe are like high pressure and low pressure systems stretched out around the planet due to its huge rotation. And within them are very small differences in temperature. So we're seeing superimposed on smaller horizontal scales the same sort of structures that we have within the Earth's meteorology.
But is Jupiter's atmosphere actually similar to Earth's? This film is a view from space, speeded up, of the Earth's northern hemisphere. Our weather is distinctly divided into different zones, hot and cold, by a phenomenon called the jet stream, seen here traveling across the North Atlantic. Could Jupiter have many jet streams at different latitudes, giving rise to its characteristic banded appearance? One faction of Voyager scientists believes so, and this is their most convincing evidence. This computer model was developed for the Earth's atmosphere, but this time they have fed in all the numbers appropriate not to Earth, but to Jupiter. And astonishingly, the model begins to develop belts and zones, just like the real Jupiter. But a growing faction of Voyager scientists refuse to be convinced by this evidence.
We thought before Voyager that perhaps all of these effects, these weather effects, the formation of the clouds and the winds associated with the clouds, were a very thin surface effect at the top of this very deep atmosphere. As a result of the Voyager measurements, though, we're now becoming convinced that the wind motions extend much deeper in the planet and may well have more to do with the interior properties of the planet than they do with this very thin surface layer.
In this experiment, two different colored layers of fluids are moving past each other, just like the belts and zones in Jupiter's atmosphere. A turbulent pattern appears momentarily, and then all is lost as the fluids mix up. Curiously, this mixing up doesn't seem to happen on Jupiter. Why?
In fact, what we see are these different islands of color which persist sometimes for hundreds of years. And this is a very amazing thing and very difficult to explain. Why should these fluid features exist for so long in the presence of all this turbulence, really? The movie here shows pictures of Jupiter taken once every time the red spot was beneath the spacecraft. That means every 10 hours the shutter was snapped. Then this is played in a sequence over and over again so you can see motion. Look to the west of the red spot, you can see this turbulent, rapidly mixing region. You can see rapid flow to the east at the equator. Just above the equator, you can see another turbulent region. And this rapid mixing makes the existence of permanent, different colored, different chemical features even more mysterious. For instance, some of these features, like the red spot and the belts and zones and some of the ovals, have lasted for decades or even hundreds of years in spite of all this rapid mixing. This movie shows motion around the red spot. You can see, for instance, spots coming over the top of the red spot, some going off to the west, some going off to the east. You can see this very turbulent region to the west of the red spot. You can see a flow down below the red spot that actually reverses direction. You can see little turbulent regions around the spots farther to the south that resembles the pattern around the red spot, but at reduced scale. again, the existence of this very turbulent region so close to such a permanent weather feature as the red spot is very hard for me to understand.
Perhaps this is what Jupiter looks like inside. Maybe the atmosphere has roots tens of thousands of miles down, deep in the fluid interior. This experiment is a working model of Jupiter's interior. It is full of water, spinning, and there's a heat source inside. Stable columns appear. If this really happens inside Jupiter, could the tops of these rock-steady columns, 100,000 miles tall, power the belts and zones on the surface and guarantee their absolute permanence? This is a computer animation of Voyager 1's passage through the Jupiter system, made using actual mission photographs. Besides Jupiter, the Voyager spacecraft were programmed to study the 4 large moons, the Galilean satellites. The moons are named after the male and female lovers of the god Jupiter: Io, Europa, Ganymede, and Callisto. The bright star is the sun. Before Voyager, virtually nothing was known about this collection of small planets. These views were the best there were. Now, all that has changed. Callisto, outermost of the Galilean satellites. About twice the size of the Earth's moon, Callisto is half made of ice. Under a frozen ocean hundreds of miles deep is a rocky core. The surface is intensely cratered. In some places, gigantic impacts seem to have converted the ice to slush before it refroze. This computer-enhanced picture shows that Callisto's surface is saturated with craters. Why? The solar system condensed from a huge flat disk of material swirling around the sun. The condensation happened about 4,500 million years ago. 4.5 billion years. The planets and moons grew from the disk by collecting up the small objects in the solar system. They were formed by an intense bombardment of meteorites, of asteroids, and of comets. The bombardment left their surfaces scarred with impact craters. This is one of those craters.
This is Meteor Crater, Arizona. It's one of the rare impact craters we find on the Earth. In fact, by all odds, it's the best preserved of about a dozen known craters that have been formed in the last few tens of thousands of years here on Earth by the impact of small bodies of meteoritic iron. Here we see a piece that was broken off in the atmosphere from the main body which formed this crater that we're now looking at. There are, of course, many, many other craters that have been formed on the Earth and have been either eroded away or covered up by sediments. And it's only the youngest that are preserved, such as this one, which was formed about 25,000 years ago. It's a little less than a mile in diameter, about 600 feet deep. And in the distance you can see the rocks that have been faulted and deformed and bent by the shock wave produced by the meteorite as it struck the ground. Now, we're interested in these craters primarily because it provides us a tool for dating surfaces on the other planets and on the Galilean satellites of Jupiter. The most heavily cratered object in the Galilean satellite system is the outermost one, Callisto, which is packed with craters tens of kilometers in diameter. To find a surface that is chock full of craters, we must be looking at a surface that is very ancient. In fact, we must be going back to that point in time in which the rate of cratering was much higher than it is today, a time in which the pieces from which the planets themselves were built were still being swept out of the region around the planets. And so we see here on Callisto an actual record of the last stages of planet formation.
From Callisto inwards to the largest moon in the Jupiter system. Ganymede. Rather bigger than Callisto, it too is half made of ice. Much of Ganymede's surface looks identical to Callisto. It's almost as if whole chunks of Callisto had been grafted on. But the rest of Ganymede's surface is quite different and unique. It is covered in grooves, strange parallel lines twisting over the surface.
Now, what we're able to see here are what geologists call superposition patterns, places where one geological structure or feature is on top of another one, indicating that it's younger. Here we have two different sets of groove patterns, this groove pattern crossing over and apparently lying on top of this older groove pattern. We have then several sets of craters, some craters which have been destroyed by this younger set of grooves, other craters which have been laid down on top of the younger grooves. Making craters that large is a very improbable event in today's solar system. So again, we believe that these processes were going on while heavy cratering was occurring, which to planetary geologists means early in solar system history.
So the grooves are very old, almost as old as Ganymede itself. How were they formed?
Now, the general pattern of these ridges and grooves suggests to us that the groove terrain's been formed by stretching or pulling apart of the crust. And the simplest explanation is that the grooves are formed over long, narrow slices of the crust that have been dropped down along faults. And the ridges are formed by the parts of the crust that are left between that have not subsided.
In other words, as the ice froze, it expanded. The surface stretched and cracked. As it stretched apart, whole sections of surface were pushed up, making depressions or grooves.
We have examples of this kind of faulting in the western United States. And in fact, rather close to us here in Flagstaff, Arizona, there is a beautiful groove that has just about the size and shape of many of the grooves on Ganymede. And it is formed over a long down-drop fault block with just about the same relief. In this case, we know in the western United States the groove is formed by extension or tensional pulling apart of the crust of the Earth. And we think that that's what is the principal cause of the formation of the grooves on Ganymede.
The grooves have recorded unusual events on Ganymede. Here they have been displaced. Is this an earthquake fault, like the San Andreas in California? If so, Ganymede is the only place in the solar system besides Earth where these faults have been discovered. But Ganymede, like Callisto, is now a dead world, a museum of its early history. From Ganymede inwards to Europa. Europa is the size of the Earth's moon. A frozen ocean slightly deeper than the Earth surrounds a large rocky core. Europa is almost perfectly smooth, like a billiard ball. The surface is distinctively covered in cracks.
Unlike Ganymede and Callisto, in which we see dense populations of impact craters on the icy surfaces, On the icy surface of Europa, we see virtually no impact record. We see 3 impact craters about 20 kilometers in diameter, but this is a very, very small population compared to the other 2 objects. Evidently, Europa had to remain young and active beyond the period of the torrential bombardment, so that its surface was continually being renewed. Instead, what we see are a complex network of intersecting dark bands, and they're thought to have resulted from the expansion of Europa as the ocean froze.
The cracks on Europa are indistinguishable from the cracks seen in polar regions on Earth. This is the ice of Antarctica. There is a color difference. Perhaps Europa's ice is contaminated with pulverized rock. What emerges is the standard history of a planet or moon. It is formed by meteor bombardment. Then part or all of the ancient cratered surface may be covered over or erased with new landforms. Even this new surface becomes lightly cratered. So perhaps the differences between Europa, Ganymede and Callisto are just a question of when the oceans froze. On Europa, the meteorites splashed down into a liquid sea, which only froze afterwards, so there are virtually no impact craters. On Ganymede, the ocean froze at about the same time the bombardment stopped, erasing some of the original cratered surface with grooves. But on Callisto, the ocean froze before the end of the bombardment, making the surface a museum of the violent birth of the solar system. From Europa inwards, towards Jupiter. Here, the spacecraft encountered Io.
I think it's fair to say that one of our biggest surprises with Voyager was Io, the innermost of the Galilean satellites. And it was really rather hard to surprise us with Io. We already knew enough about it to know it was one of the more bizarre objects in the solar system, but even so it managed to astound us when we actually got there.
Io is the size of the Earth's moon. Its surface is like nothing ever seen before. The stage was set for the most important discovery of the Voyager mission. And it wasn't made by a scientist, but by an engineer.
4 days after Voyager 1's historic encounter with Jupiter, I was doing my job of optical navigation and looking at pictures of the satellites of Jupiter and stars to tell us where the spacecraft was. In so doing, I was looking at a picture of Io in particular, and this is the frame right here. I expected to see the satellite Io and 2 stars in the frame. I used the capabilities of my computer to enhance the signal of a very dim star. And in so doing, I noticed the appearance right off the limb of Io of an anomalous crescent. And my first impression was that this crescent was another satellite behind Io. By analyzing trajectory geometry printouts of what objects might appear in this frame with Io, it was determined that no known satellite would appear in this frame with Io at that time. My next thought was that, well, this was perhaps a newly discovered satellite, but at this distance, this object would be too large and too bright to not have been discovered before from the Earth. I contacted a camera expert who informed me that no known quality of the camera could induce the appearance of this anomaly. Therefore, the only alternative that was left in discovering what this anomaly was that it in fact did have something to do with the satellite Io. I have determined the latitude and longitude in the region of this crescent on the surface of Io. This turned out to be the latitude and longitude of a large heart-shaped feature on Io, already known to be a volcanic feature, but of course not ever believed to have been an active volcano. I concluded that what we were definitely witnessing was an active volcanic eruption and that the crescent itself was a volcanic plume, a dust cloud of gas. an actual volcanic eruption, the first ever witnessed on a body other than the Earth in our solar system. The other bright spot down there is also another volcanic eruption. What we are observing here in the discovery frame was in fact two simultaneous volcanic eruptions. The surface of Io is incredibly active, much more active volcanically than even the Earth. Had the discovery not taken place when it did, we would not have been able to reprogram Voyager 2 to take a time sequence of frames and actually produce a movie of this incredible phenomenon.
This is the black and white movie. The volcano was named after Linda. Computer enhanced, the pictures show the incredible violence of the volcanic activity. And the depressions that litter Io's surface turned out to be not meteor impacts, but volcanic craters called calderas by geologists.
We found out that not only was Io's surface being modified by volcanic processes, it was being done so literally in front of our eyes. There were active volcanoes going off at the time we were there with Voyager 1, at least 7 or 8, perhaps 9, clearly identified explosive volcanic eruptions, throwing materials hundreds of kilometers above Io's surface in the force of the eruptions. This picture shows two different volcanoes which are seen from several different angles to give some perspective. Here we see ejecta coming out from the center of the volcano falling back down to the surface. Here we see it lit against black sky so that the symmetrical form of the eruption, much like a sprinkler head, and that's throwing material up approximately 70, 80 kilometers in that view. Io shows us nearly the full range of volcanic type landforms, and in this picture very prominently displayed are at least two calderas, volcanic depressions with what look like lava flows spreading out from them. It also shows several diffuse features which look like they may have been something more explosive, like the pictures we just saw, where the material has come out and covered up the surface in a more diffuse manner. Based on our estimates of cratering flux in the region of Io, we estimate that this continual resurfacing of Io amounts to spreading a layer or blanket of volcanic material of about 1 millimeter thickness over the entire planet every year. Now that rate, if it continued over geologic time, would amount to essentially turning Io inside out.
Io is volcanic because of its location, sandwiched between the giant planet Jupiter, seen here in this Voyager movie, and the other large satellites which can be seen orbiting around. Io raises a tide in the huge atmosphere of Jupiter in exactly the same way as our moon raises a tide in the Earth's ocean. The gravity of the moon distorts the seawater of the ocean into an oval. Because the Earth is spinning, this oval is swept forward and always points ahead of the moon. So the gravity of the oval accelerates the moon forward and pushes it out into space. The tides are gradually throwing the moon out, away from the Earth. And that's exactly what Jupiter's tides would like to do to Io. But the orbits of Io, Europa, and Ganymede are locked together in a quite extraordinary way. We are now looking down on the surface of Europa, and the other moons and Jupiter appear to be orbiting around. For every one orbit Ganymede makes, Io makes exactly 2. The orbits are locked together, and the effect of this on Io is to hold it firmly in place. So poor Io cannot move. It is held in place and alternatively pulled and stretched by the immense gravity of Jupiter's tides. The heat of this constant deformation has melted the interior. Only a thin crust of sulfur and rock sits on a ball of molten lava. And that's what causes the volcanoes. They are powered by sulfur dioxide boiling at -300 degrees centigrade.
The concept of something boiling at 300 degrees below zero or so is difficult perhaps for most people to imagine. And what we have here is, just to demonstrate this, is water and liquid nitrogen, which like hot rock and water on the Earth and like sulfur and sulfur dioxide on Io, differ in their boiling point so much that whenever they mix together, there's an explosive eruption. In this dewar, we have some liquid nitrogen at a temperature of about 350 degrees below zero is already boiling. And when we warm it by putting it in contact with the liquid water, it explodes into a cloud of steam. The result is a massive expansion of gases below the crust of Io, resulting in an exhaust, much like the exhaust of a rocket engine through a pipe up to the surface, in which the gases expand and violently erupt into the air.
The Voyager pictures show a vividly colored surface. Could just volcanic sulfur provide all the brilliant colors that we see?
We'll start out with the simple kind of sulfur you'd buy from your pharmacist, called flower sulfur. It's simply yellow sulfur. As a matter of fact, on Io, at very, very cold temperatures, this yellow sulfur is virtually white. What we'll do is heat this gradually. You can see the color starting to slowly change. This is the next form. It's an orange form of sulfur. If we were to cool this very rapidly, this sulfur would retain its color. As the sulfur continues to change, it becomes redder and very liquid. So some of the flows that we see on Io, which are orange and red, suggest that this very runny form of sulfur froze, retaining the color. As we go to higher temperature now, the sulfur changes again to a deep red and becomes much more viscous, like syrup. It runs much more slowly across the surface, forming cliffs on the flow front. And then the highest form, you can start to see here, changing, is a virtually a brown to black form. It's this form of sulfur we see on the black spots that are scattered around on the floors of the calderas on Io. Suggests that the materials on the floors were heated to much higher temperatures, in this case about 300 degrees centigrade.
Some of the sulfur spewing out of the volcanoes escapes Io's gravity and forms a wake along the orbit. It forms a ring or torus of sulfur atoms. This has now been seen by Earth-based telescopes. In this circular photograph, it is just possible to make out the ring of sulfur atoms. The sulfur from Io's volcanoes is probably also the reason for the red color of Amalthea. This potato-shaped object is about 300 miles long and orbits inside Io. Before Voyager, Jupiter was known to have 13 moons, and most of them are probably rather like Amalthea. But a young graduate student discovered a 14th moon inside Amalthea. The discovery frame shows the as yet unnamed moon as a bright streak. Most spectacular of all, Voyager discovered that Jupiter, like Saturn, has a ring. Here it is seen backlit by the light of the sun. Here, in this black and white enhanced picture, lightning bolts flash in the cloud tops of Jupiter itself, brighter even than the most powerful lightning on Earth. Ever since the First World War, it has been known that Jupiter is a strong source of radio interference. The Voyager spacecraft carried on board an instrument very similar to an ordinary car radio. The aerial was somewhat longer, about 30 feet long. This instrument listened to the actual sounds of Jupiter and broadcast them back to Earth. Jupiter's immense magnetism confines a region of space 10 times larger than the Sun, which encloses all the Galilean satellites, the magnetosphere. This is the sound as the Voyager spacecraft enters this region. Inside, it's like a microwave oven. The trapped radiation makes strange tones, like whales. Close in Io's sulfur torus, there is a sound like birdsong. And lightning on Jupiter generates distinctive whistlers, falling tones. These radio effects are still very largely a mystery. The Voyager spacecraft sent back over 33,000 photographs to mission control. The data will take years to analyze, but there are already plans to return to Jupiter. Mission Galileo will be 2 spacecraft. One will dive through the clouds into Jupiter itself. The other will orbit around. Launch date is set for 1984 aboard the space shuttle now under test. After launching the spacecraft, the reusable shuttle will return to Earth. Back at JPL, a man known by the formal title of Ace is controlling the Voyager spacecraft. His team of scientists and engineers is hard at work. For the 2 Voyager spacecraft have hardly started their epic voyage. They are now in transit from Jupiter to the giant ringed planet Saturn. Voyager 1 arrives on the 12th of November, 1980.
Next week in The World on Monday, the remarkable story of 2 killer whales and the fund of knowledge they're giving to scientists in Holland. The Gentle Killers, next Monday at 8:25. Due to an industrial dispute in our Public Affairs Department, there'll be no Nationwide tonight. Next on ABC, the mid-evening news, and at 10 o'clock, Sight and Sound in Concert.